Hi all, I received this homework question and I wanted to address it in a video. So the homework question is asking us to reduce this fraction that contains both radicals and negative exponents. Over on the side you'll see two rules that we're using. The pink one is telling us that if we have two radicals stacked in a fraction, we can turn that into a single radical over the fraction. And the yellow rule is telling us if we have a variable with a positive exponent over a variable with a negative exponent, it essentially turns into addition. If you're looking for more information on that particular rule, it would be in a previous section. Okay, so the first thing I want to do is apply my pink rule, which is 3 over 5 times, and I'm going to separate and write this fraction containing two radicals as a single radical containing the fraction. So single radical where the numerator is 100, x to the 6th, and the denominator is 5, x to the negative 1. So now I have fractions and I want to be able to reduce these fractions. So I have 100 and I have a 5. This 100 will reduce with this 5 to result in 20, because there are 5 $20 bills and $100. And this negative exponent on the x will reduce with the exponent up here as a plus 1. So rewriting this statement, I would have this is equal to 3 over 5 times the square root. There's nothing left in the denominator anymore, so I just have the square root of 20 times x to the 7th now, because this negative exponent moved up into my numerator. Okay, so I have a square root and I have stuff that has perfect squares within it, so I'm going to rewrite this as 3 over 5 times the square root of 5 times 4 to make 20, but that's really 2 squared. So I'm just emphasizing the fact that I do have a perfect square there. Now, over on the other side, let's look at x. So x to the 7th can really be written as essentially 7 x's, and then I can group them however I want. So 1, 2, 3, 4, 5, 6, 7. I have 7 x's to work with, and I have a square root. So I'm going to try and group them in twos. I have a group of 2, and a group of 2, and a group of 2. And then I have this 1x left over. So I have 1, 2, 3 groups of 2. I'm going to rewrite that in here as my 3 groups of 2. And then my 1 leftover x to deal with. So now I can reduce this further by taking out my squares. I have a square here and a square here. When I take them out of the square root, the square will essentially go away. So this is 3 over 5 times 2x cubed times the square root of what was left over inside my square root. So this is now gone, and this is now gone. They've been rewritten here and here. So what's left over is 5 and x. So I have times 5 x. Now I just need to deal with the math on the outside here. So I need to multiply the 2x times 3 times this numerator, because this is really over an invisible 1. Let me erase this extra line down here. So that would really give me a 6 x cubed times the square root of 5x, and this 5 is in the denominator of everybody, so I can just write him down here. Okay, I hope I helped that with that particular question, and I'll see you soon.